On this very stage a couple of years ago, Preston Manning said that Canada is the only country that owes its foundation to the relentless overexploitation of a rodent. That's our very own beaver he's talking about. So, we've had a speaker here previously talking about the beaver, and the focus was on the beaver as a hydro engineer, a miraculous and fabulously industrious little hydro engineer. But we didn't know very much about how beavers communicate with each other. And so to continue with the story of our national beaver, we've invited Dietland Müller-Schwartz to come and tell us, how do beavers communicate with each other? How are you?
Thank you.
Dietland?
Moses, thank you for inviting me to speak here today. The beaver is the national animal of Canada, of course, and we have been studying it for about 40 years now. I'm going to talk about the right chemistry, meaning we have studied the chemical communication of the beaver. We all know these huge lodges and the tremendous high dams, or the extensive beaver meadows. But what about the more subtle things that most of us don't normally see? May I ask you, how many of you have seen scent mounds in beaver country? Yeah, this is the hidden world, and that's why I'm here to tell you about it. The beavers make scent mounds that you don't normally really see. You may stumble over in, or may step on them, but if you look for them, and you really have to look very closely, you have to smell them. You have to bend down. You see here my daughter do it, my assistant do it, myself, and we all do the scent mount stretch. We do it all the time, and you notice this way whether there are new beavers in the area, whether there's fresh scent, whether the site is abandoned. Already our human nose can extract a lot of information from these scent mounds. Now, why is this important? We have, in recent years, discovered the very, very important role of the beaver in water management, especially in the arid West, where we have a reduced snowpack, and we would like to retain the meltwater that's flowing down the streams. So we want to reintroduce beavers to regulate the water. Particularly impressive is it in the Missouri-Ohio River watersheds. An engineer, Donald Hay, has calculated that if we were to reintroduce only 3% of the original beaver population in the entire watershed, we could prevent these catastrophic floods that we had in previous years. You might remember the big floods of '93. Only 3%. In the drier, arid western areas, attempts are being made to reintroduce beavers into Oregon watersheds to regulate the water, and in Utah in the Escalante River watershed. So, what can we say about the beavers, and how can we study the scent mound behavior which occurs at night? We have in the past looked at whole populations and in areas that, where there are lots of beaver and in areas where there are few beavers. In fact, I can go to one particular beaver site and look at their scent marks or the scent mounds. These are little mud piles where the beaver marks on, and we can tell, are there more beavers in the entire area? Because with increasing population density and more contact between the beaver families and more strife and competition, there are more scent marks. And you see this here. If you look at the lower axis, you see the number of colonies we see in the neighborhood that is in about 5 kilometers upstream and downstream. And the number of scent mounds is on the vertical axis. So you see, if there are few scent mounds, there's only one or no colony in the neighborhood. If there are a lot of scent mounds on the upper right, then we can be sure there are a lot of neighbors, a lot of contact, a lot of competition going on. Now, where do these beavers produce their scent? Where is it coming from? And now here we have an area where on the one hand, a lot is known for centuries, going back to the Roman times. We have known about these castor sacs you see on the right. Today, the Romans used them for medicine, for ailments such as flatulence, abortions, and other things. So there's a long history, and in fact, today you still can buy homeopathic preparations made from beaver, so-called castor or castoreum, which is produced in these castor sacs. It is very variable. It depends on the diet the beaver eats. In fact, in the castoreum, we find compounds that are in the trees that the beaver feeds on, whether they be willow or wild cherry, aspen, and so forth. And one particular component in this beaver castor is the salicin, or salicylic aldehyde. Does it ring a bell? It is aspirin. So the beaver never gets any headache, we assume. And this has been extracted and used by humans, of course. And in fact, beaver castoreum is still today available as homeopathic preparations. And then there is the other set of glands that they have, the oil sacs, which doesn't vary so much with the diet, which is more standard, more genetically controlled, and that is also used in marking. Now, they use they mark their territory with these glands. The perfume people and the medical people have known this castoreum for a long, long time. But the question is, what does the beaver do with it? What do they have it for in the first place? And until we started this research decades ago, very little was known about it. So my students and I, we did a number of series of experiments. But how do you do experiments? How do you ask a beaver, what do you do with your castoreum? First we have to get the castoreum, and then we have to play it back to them and say, what do you think about it? So it's pretty elaborate. We have to catch them in live traps. We catch them, then we have to tranquilize them, and then we milk them. So it always looks good in your resume, special skill, milking beavers. So here we are collecting castoreum, and those two little organs that you see are the oil sacs or anal glands. And the castoreum comes out in between. You see that liquid there, and that's what we collect. We collect it from known individuals. We trap them. We look what age they are, what sex they are, and then we ear tag them with colorful tags that when we find them again, we know who is who. And we did this for a whole population in a state park in New York State. Then, now we have a whole collection of beaver castoreum in our freezer or refrigerator. We have it from adult males, adult females, juveniles, yearlings, you name it. And then we play it back. How do you ask a beaver what he or she thinks about a certain type of castoreum? How do we do this? We have to develop a bioassay, which means we play it back to them in nature in a meaningful way, not in captivity, not in a cage, but in their normal environment out in the beaver country. So we didn't have it as easy as these hunters. Here, the hunter wants those castor sacs from the beaver, but the beavers don't want to be killed just for that. So they bite off their castor sacs and hand it over to the hunter and ask him to spare their life. So that is an illustration from a book about beavers published in Augsburg in Germany in 1685, Castorologia. So we built a scent mound just like the beavers do. We work in the mud, make a pile. In order to confine our sample, we would put something in the middle, like a cork, to keep the scent mark there. As we set it up, we have a pair of scent mounds. On each cork, we have a sample. Say, for instance, one is of the male of this particular colony, which should be a familiar animal. And the other has perhaps the male of a neighboring colony or of a total stranger. And then we wait for things to happen. In the evening, beavers come out, and we can observe them directly, what they're doing to each scent mound. And then you see the one on the left they have destroyed, the one on the right they left alone. If it's a familiar odor of an animal that's not threatening to them, they just sniff it and that's it. Oh, I know that. However, if a strange beaver enters their territory and puts a scent mound there, dredging up mud and marking it with their glands, this is outrageous. This has to be dealt with immediately. The beaver come out and in the evening, and before they even feed or relieve themselves, they smell the strange odor in their territory, and then they go at it and destroy it. Now you have the sequence here. A beaver approaches our experimental scent mound, sniffs it thoroughly, and that may be it, if it's familiar and non-threatening. But then it may paw it apart with their front paws and go over with their rear end and mark it with their glands, actually the two types of glands. Now I want to show you that sequence that I showed you just in single stages is a little video. There's our pair of artificial scent mounts. The beaver comes out, sniffs it, and you will see it treats the two mounts differently. You can only see this here. Marking. Cord goes. Now he dumps some mud on it, covers the scent. Sniffing for the intruder. So most of us will never see such behavior. You have to really set it up to be there at night. By the way, if you are interested, I have the actual smell here for you. You can see me afterwards. With all this technology here, you still need the odor projection. So now what did we find out? Well, how well do beavers discriminate different individuals? They can tell their own family members versus the neighbors, which is very important because you don't want to argue with your neighbors all the time. It's called the dear enemy. You know your neighbor, you have to be wary of them, but you don't want to fight all the time. They can distinguish the odors of their neighbors versus total strangers from another watershed. They can distinguish the odor of adults versus the non-threatening juveniles. And here it gets even more exciting, kin versus non-kin. But that is based more on the oil sac secretion than the castor sacs. And possibly much, much, much more. We have just scratched the surface. Here is the kin recognition. It's done by a student of mine, Li Xing Sung. You have on the left, we have a pair of beavers at one site, one colony. And in subsequent years, they have young, and then the next batch of young the next year. One of those young, B1, disperses to another site and takes a mate. These have young in turn, which would be the grandkids of this pair. And say they are 10 kilometers away. We don't know whether they ever visit back again. It's unlikely because they have to travel through hostile territory of other beavers. So if we take the castoreum from these grandkids of whom we assume they are not known to their grandparents and play it here, they treat it gently. Somehow they recognize it, they can distinguish it from members of other families of strangers. Now, we can do something else besides studying what they can discriminate. We can try to prevent areas from being colonized by mimicking occupancy. We make a mixture of castoreum and the oil sac secretion from both an adult male and an adult female, meaning we make a kind of a family odor, and place it in areas that are attractive to beavers, where some home-seeking beavers might settle, but they won't after it's experimentally scented, as long as there are other choices available. It works in populations where not all sites are occupied. And the game management people usually aim at beaver populations. There should be only 30% occupied, so that the other 70% are there for dispersals to go to. Now you might wonder, what is this castoreum composed of? Well, it's a lot of different compounds, and many come from the trees that they eat. Beavers actually recycle the defense compounds that the trees produce for not being eaten, and they recycle it for their own purposes, i.e. scent marking. And you here have a graph. The details don't matter, but at first people thought, could you not distill out the single compound in there that really makes it a beaver odor? The answer is no. It's a gestalt. It's a complex odor. If you, this is a castoreum, and we have the response strengths in terms of how much, how long they sniff, and how intensively they destroy the scent mounts. So this is a strong response. Then instead of having 30 compounds, so if we just take a mixture of 6 compounds, we still have a strong response, but not as big as to castoreum. And then these single compounds, ethyl, phenol, cresol, etc., are very little active. They smell it smells like beer, but not quite right. It got not right. So how can we use this? Why is this important? It's intellectually very, very interesting to figure out what they do and how they communicate, but we can also apply it. In the beginning, I told you that we want to use beavers for watershed management, for building their dams and wetlands to retain water in higher elevation and that it gets released very slowly. So we can use it. The knowledge of this scent communication we can use as an important tool to attract beavers to a certain site. As long as we know what we are doing, what attracts them, and usually single individuals, they attract a potential mate. Or we repel beavers, then we take the potent mix of a whole family that says, occupied, stay out. And we can also use it, as I showed this in one graph, the more scent mounts we find at one site, the more beavers are in the general area. We can use it to monitor populations. So and with that, I thank you very much.
Thank you, Dieter.
Thank you.
This odor that you have in that little capsule, how awful is it?
You can try.
Oh, yes. Do I want to? And
careful.
will it propagate a long distance?
Not really.
It won't
well,
stay
it's supposed to.
I can't smell very much
It
at all.
is used in perfumes and it's supposed to impart an animal note, a wild animal note.
And perhaps for another visit and another lecture, you were saying that thing about them gnawing off their, what do you call them, and it made me
castor
strangely uncomfortable. Thanks very much.
Thank you, Moses.
A picture, yeah. No, I was expecting the worst. It's okay. It's actually quite subtle.
Yes. So see me afterwards if you want to smell it.